Alright, this is Mac 1105 College Algebra, Chapter 3, Section 3, dealing with functions again. This is properties of functions. Alright, first of all, we talk about even and odd functions. Alright, an even function is where if we put a negative x in to the function, it produces the same thing as if we put a positive x in. So what happens here is that if we put a negative 2 in, let's say for x squared, we get a positive 4. If we put a positive 2 in there, we get a positive 4. See how the negative and the positive x gives us the same value of y. Also, looking at even graphs actually are flipping over each other. So this could be an even. If we had one on over here, it could be even. It just depends on whether you have a positive negative x. Odd functions are where when we stick a negative x in, we get a negative y. Cube function is odd. In terms of this, if we stick a negative 2 in to the cube of x, we get a negative 8. Put a positive 2 in there, we get a positive 8. An odd function, graphically wise, is flipping it over and down. Let's look at example 2. This is where we do it algebraically. Okay. Looking at it algebraically, if I have f of x equals x squared minus 5, see how the x squared is positive, the 5, it has a minus sign. So when I stick a negative x in there, the negative x comes here, it's squared, becomes positive. See how nothing has changed. See how the x squared is still positive, still has a minus in front of 5. So because nothing has changed in any of my terms, the sign hasn't changed in any of my terms, this is even. When we come to letter B, in terms of letter B, I have x cubed minus 1. When I put a negative x in there, the negative x cubed becomes a negative x cubed. However, the 1 still stays a minus. See how the first term changed sign, the last term did not. They both either have to change or not change. A better way to put it is that every term in your function must either keep the same sign to be even or change all the signs in order to be odd. If one changes and one doesn't, it's neither. Okay? Another hint is if I have a constant, which the minus 1 here is a constant, that function can never be odd. It can only be neither or even. Coming down to letter C, there we have the positive x being 5x cubed minus x. Notice that there's a positive in front of the 5, minus in front of the x. Put a negative x here and a negative x here. Do the math. See how the sign changes in front of the 5. The sign also changes in front of the x. Because both signs changed, this is odd. We come over to letter D. This is the absolute value function. So if we put a negative x in there, absolute value of a positive or a negative is still a positive, so this is even. Going to example 3 in the book here, this is just looking at some graphs and determining if it's even or odd. Hope you can see here that this is even, because this is just a flip over. Hope you can see here this is neither, because if we were to take from the y-axis here and flip it over, we'd actually get a W, and we don't. This is odd, because this flips over and then down. Now we start talking about increasing and decreasing. Basically, you define a graph being increasing and decreasing by intervals. So for instance, we come from left to right, so we're coming from the left to the right, and x values are what we use for our intervals. So from bracket negative 6 to bracket negative 4 is decreasing. See how it's going down. From parentheses negative 4 to bracket 0, it's increasing. We don't have to include this one because the graph from here to here is constantly increasing. And when you come here, there's a bunch of schools of thoughts on this. I could have said bracket negative 6, parentheses negative 4. I'm not going to be so much particular in terms of whether you put a bracket or a parentheses. It's just that you can't put a parentheses for both uses of -4. In other words, I can't put bracket -6, parentheses -4, and then go parentheses -4 to bracket 0. Here, from bracket 0 to bracket 3 is a constant, because it's all in the same line. And from parentheses 3 to bracket 6 is decreasing. So see how it's decreasing here. Pen, make it easier. See how it's decreasing here, and at this point here it starts to increase. When it gets to here, it becomes a constant. When it comes here, it decreases. That's all you're doing, and you define increasing, decreasing, and constant by intervals. Local maximum and minimum is another concept, okay? Local means that if you look at an interval, okay, is there a maximum or minimum point? So in terms of this one right here, this -1, 1 would be a local minimum for this interval. This 1, 2 would be a local max for this interval. Okay. We come down here to this 3, 0. This would be what's called an absolute minimum. In other words, this is the as low as the graph goes. So this is absolute. In other words, the graph will not go any lower than 0. So local minimum, local max, and the reason this is local max is because we got points up here that are higher. And this is an absolute minimum. You can see from the graph that this is as low as the graph goes. See, this isn't an absolute max because we have points higher than that. Let's just look at some of these graphs. And okay, so here we have an absolute minimum. Here we have an absolute max. Here we have a local minimum, local max. In terms of here, we have an absolute max, local max, no minimum. That's an open point. Absolute max. Here, we have a local max, absolute max, no minimum. And then here, we only have a absolute minimum, local minimum. We come to this last one, we actually don't have a minimum because we have an open point here and this goes on forever. We don't have an absolute max because there's points higher than this. This is just a local max. We talk about rate of change. Make sure you understand that rate of change is nothing more than slope. So, where we have learned before that delta y over delta x is y2 minus y1 over x2 minus x1, this is saying the same thing, but just in function notation. Remember, f of b is a y. F of a is a y. So this is y2 minus y1. B and a are x's, so this is x2 minus x1. So it's the same principle. Okay? In other words, and I kind of messed up here, this is f of b minus f of a over b minus a. Remember, this right here equals y2 minus y1 over x2 minus x1. This problem here, it says, find the average rate of change. Rate of change is slope for f of x equals 3x squared. From 1 to 3, so they're giving us our x's. Our x1 is 1, our x2 is 3. So the first thing we do is we do the slope. We find our y's. Sticking 3 in here, 3 squared is 9, times 3 is 27. Stick in 1 in here, 1 squared is 1, times 3 is 3. That's how they're getting the 27 and 3. 3 minus 1, do the math, we get 12. We come to the second one here, we're going from 1 to 5. Here's our new x's. So we stick 5 in here, we get 75. 1 in here, we get 3. 5 minus 1, we get 18. Last one's 1 to 7, new x's, x2. So we find f of 7, which is 147, minus 3. 7 minus 1 equals 24. Remember, rate of change is slope. So when you see that f of b minus f of a, it's really y2 minus y1. When you see b minus a, it's really x2 minus x1.